Testing. Hello, class. Today we're going to begin Chapter 5. Chapter 5 is a lesson that looks at a lot of different personal finance experiences that you are likely to run into in the next 5 years or so. We'll be looking at multiple ways of calculating interest. There's a huge amount of ways to calculate interest. We're going to look at some of the most basic that you are likely to encounter just as an average citizen over the next 5 years. We'll talk about which types of interest are good types for us as a consumer, which ones are not. We'll also talk about just some personal finance decisions that we should be making in terms of our own finances, and I'll mention that as we go along. This particular lesson will be a fairly short one, so that'll be kind of encouraging. I will be assigning this section 5.1 on this Thursday, and it'll be due then next Thursday as well. So we'll have that one due. It'll be listed when it's due also on Blackboard. To enter into this chapter, we need to understand about 5 or 6 terms that are used frequently. So that's what I'm going to review here first. The first term that I'm going to look at is the principal. Principal is the original amount of money lent or invested. So it's what we started to put into an investment or what we borrowed originally from a bank or a lending institution. It's the original amount that we start off with. The balance, sometimes referred to as outstanding balance, is an amount that has been, when an amount has been borrowed, it is the amount of the principal left to be paid off. For example, let's say my principal, I borrowed $10,000 and I paid back 1,000 of it, and the balance would be 9,000, 10,000 minus the 1,000 I paid back. So whatever I still owe is the balance. If I've invested an amount, for example, let's say I invested $10,000 into a particular stock. If after 1 year that 10,000 investment has grown to 11,000, then my balance would be 11,000. It's the value of the account currently. The future value, sometimes called the maturity value, is the total amount of money a lender will get back when you're borrowing. For example, if I borrowed $10,000 and I pay it all back plus the interest, say I pay back $500 of interest, then the future value would be the $10,000 plus the interest. When I'm investing, it is the total amount the account will be worth when we cash it out. If we haven't cashed it out yet, then the account would have a balance. But once I cash it out, that's referred to as the future value, the maturity, when the account has gone through its particular cycle. Three other terms. Interest rate. I've underlined the word annual here because that's the way it's usually listed. Interest rate is the annual percentage usually charged on the unpaid balance, not always. This will be one type of interest. This can vary considerably from one type of loan to another. The only time they don't use an annual percentage is usually with credit cards. Credit cards will give a monthly percentage. It makes it look much better. For example, many credit cards will charge 18% interest annually. That's a very high amount. It's why credit cards can be quite dangerous. If their annual percentage is 18%, if I divide that by 12, I would get a monthly percentage. So the monthly would be the 18% divided by 12. The monthly percentage then would be 1.5%. That sounds pretty good. 1.5 seems to be a low number. But when it's a monthly rate, 1.5 per month corresponds to 18% annually. That again is a very, very high interest rate. That is why you have probably heard warnings from your parents. Be careful with credit cards because they charge an enormous amount of interest. That is one of the big dangers of credit cards. Term is the length of time before the debt is paid back. So if I borrow some money for 3 years, the term would be 3 years. If I invest some money for 5 years, the term would be 5 years. Simple interest, it's the most basic of all the types of interest. Simple interest is the amount of interest computed as a percent per year of the original principal, original amount. Okay, so we're going to start looking at some problems dealing with simple interest. By the way, this simple interest then would be my principal, P, multiplied times my interest rate, R, that's an annual rate, times the time, T. That's our formula for that. It would look like this, and you should copy this one down. Put down simple interest formula. The simple interest I, which you see in this formula right down here, it's equal to the principal, P, at an annual rate of interest, R, for T years. Couple of things I want to emphasize here. The T is in years. So if I am calculating simple interest for 5 years, T would be 5. If I'm calculating a simple interest for 1 year, T would be 1. If I'm calculating T for a number of days, let's say 90 days, that is a fractional part of a year. They're expecting this to be a yearly time. So if I have it for 90 days, the actual time in years would be 90 over 365. It would be some decimal. We'll be looking at both years as well as days. Let's start off with a particular example here. If I invest $1,000 at 8%, for 3 years, how much interest would I receive? This is as simple a problem as we'll get for interest. We're looking at simple interest. It told us that. That formula for simple interest was the principal times the rate times time in years. So in this case, my principal is $1,000. My interest rate, which I'll write as a decimal, 0.08, that's 8%, for 3 years. That's going to be my simple interest. When I calculate that all out, multiply it out, I get $240. Very easy, straightforward problem. What would my total investment be worth? Well, it's not worth just $240. That's how much I gained. That's how much interest I received. My total investment it's going to be the original, which we call the principal, plus any interest. My total investment will be the original 1,000 plus any interest. So my original principal was 1,000, added to the interest, which I found over here to be 240. So my total investment would be $1,240. That would be the value of my investment. That value we refer to as, and we talked about this earlier, future value. It's what it would be when I cash it out. What we just got done doing was calculating a simple interest future value formula. The future value of some principal, P, at an annual rate of interest, R, for T years. That's really our formula. Where did it actually come from? Well, just like we did in the previous example, I took the original amount plus the interest. The interest was technically the principal times rate times time. That's how we got that previous $240. What we can do algebraically is take this principal P, factor it out, and I'm left with the parentheses R plus or 1 plus RT, which is that formula. That's the formula I should copy down for simple interest future value formula. It's one that we will be using frequently. Okay? Make sure that you have that one copied down. I'm going to now take a bunch of examples. Here is our first one. If you own a clothing store and you would like to borrow $240,000, 4.8% for 90 days to purchase inventory, this would be for your clothing store, for the upcoming summer stock. Find the amount of interest on the loan. Okay, they're implying here simple interest, even though it wasn't written. That formula, you remember, interest, simple interest, was equal to our original principal times rate annually times time in years. So in my case, my amount that I'm borrowing is $240,000. My interest rate is 4.8%. We have to write it as a decimal, so I need to move that decimal point over 2 places, 0.048. And then I need to calculate my time. My time happens to be in years for the formula, but they gave me days. 90 days is a fractional part of a year. They use 365 days in a year, so that fractional part would be 90 over 365. That's my T value. So I write that in, 90 over 365. This will be a decimal value, taken times that decimal value, taken times 240,000. And what we end up getting for an answer is $2,840.55. It'll be important that you can work your calculator through these. So always practice these calculations and double check these answers to see if you end up getting those. All right? Keep practicing those throughout this chapter, because that's one skill that you're going to need to master, is being able to go from the substitutions and then through your calculator to get the answers. So keep practicing those throughout this section. Okay, another problem, similar, like to borrow $150,000, 6% for 150 days. Find the future value. That's a little different. Last time we found the amount of interest. That meant we used a simple interest formula. Here we want to find the future value. Well, that formula, you recall, future value, it was equal to the principal multiplied times 1 plus RT. So now I need to use this formula instead. So my principal is 150,000. One plus my interest rate as a decimal would be 0.06. 150 days is again a fractional part of the year, so that's 150 over 365. That's the substitutions. Most people on their calculator, you can use the brackets, but because you got double brackets here, most people would probably work from the inside out. They would say on your calculator, punch in 150 divided by 365, enter, gives you that decimal, times 0.06, enter, gives you that whole product, plus 1, enter, gives you the whole brackets, times 150,000, enter, and you would have your answer. The future value in this case, this would be the total amount that you would have paid back, would be 153,698, rounded off to the nearest cent, I believe turned out to be 63 cents. Again, be very sure you can take these numbers and run them through your calculator to get this answer. Super important. You have to be able to do that on the test. These next examples are designed for us to have to solve for a particular variable out of the formula. For example, we're asked to find the interest rate on this particular problem. Imagine you own a clothing store, you would like to borrow $300,000 for 2 years to purchase inventory for the upcoming stock. The future value, that's a value that we have been always having to find. Now they're giving us the future value. Well, that's the future value on a simple interest loan. This is that formula again. We've seen it before, 1 plus RT. This time, they've given us all the values except the interest rate. They're not going to give us this R. We're going to have to figure out that R in this case. So let's take a look at doing that. The future value is 332,400. The original principal, the original amount was 300,000. 1 plus our interest rate, R, times the time in years. This one is not in days, it's already given in years, so I can plug that right in. Now we got to do some Algebra 1 basic skills. First thing I would probably do is to divide everything by 300,000. So I'm going to take 300,000, divide it into both sides. Those would cancel, and I would be left with 1 plus 2R. This side would be some decimal. I'm actually going to do that division right here now in my calculator. 332,400 divided by 300,000 gives me 1.108. Next, I'm going to subtract 1 from both sides. That leaves 2R on the right side. When I subtract this 1 away, that will eliminate that. It's going to leave just the decimal portion, 0.108. Then I'm going to divide both sides by 2, because that will allow me to solve for R. When I do that division by 2, I get 0.054. Writing it as an interest rate, I move the decimal over 2 places. 5.4% is the interest rate on that loan. This next example giving you a chance to read through it once. This time they want me to find the length of time on the loan. The simple interest is worth this amount. That's like a ending value for the simple interest formula. You recall the simple interest formula in this case. Let me find it here a moment. Interest is equal to principal times rate times time. They're telling me the simple interest is 2,104.11. My original principal was 200,000. My interest rate is 4.8%. Needed as a decimal, I got to move the decimal point over 2 places. But now I don't know t. That's what they wanted me to find, the length of time. So I don't know the t. So in this case, I would probably multiply those 2 together first. So if I do that, 0.048, multiply it times 200,000, I end up with 9,600 here. I want to get t by itself, so I have to divide both sides by 9,600. So if I do that, 2,104.11 divided by 9,600, I end up with 0.219178. It seems like an unusual answer, but it's correct. But make sure we understand what this is. This refers to our time, but remember the time for simple interest in that formula is in years. So this really is 0.219178 years. That's a decimal part of a year. If I wanted in days, I would take that number, that decimal portion of 1 year, and I would multiply it times how many days in a year. Then that would give me the amount of days that this problem is asking for. In this case, this will round off to 80 days. Now I could have technically listed this answer as long as I labeled it in years, or I could have listed this answer as long as I label it in days. Usually when there's a portion of a year, they transfer it into days. If it's over 1, then they oftentimes will leave it in years. Our last concept here today, I'm sorry, our second to the last. We're going to look on add-on interest. This is actually a type of interest. It's different than simple interest. Add-on interest is a simple interest charge, but it's distributed equally over each payment. This is the type of interest that's usually done for car loans, appliances, electronics, and furniture. Many of you are probably going to purchase a used car. It will usually be add-on interest. Many new cars will also, if you have to borrow, have add-on interest. Appliances almost always, electronics always, furniture always. These are all very common ones you are likely to encounter over the next 5 to 10 years. I need to tell you though, this add-on interest is actually kind of a ripoff. It's a different type of ripoff than a calculator or than a credit card interest, but it's still not as good as it could be. We'll try to talk about why this is not necessarily a great for the consumer or for you, all right? It's the simple interest charged on the loan that is distributed equally over each payment. What does that mean? It means that my monthly payment, and you should copy this formula down, the monthly payment for add-on interest, that would be your monthly payment for your car loan or for your appliance or electronics. Your monthly payment is the future value of the loan divided by the number of months. You remember that future value, it was equal to, and you could copy this down as well, it's equal to that original principal times 1 plus RT divided by, again, number of months. This formula you should have down in your notes. You would probably put it on your cheat card when you take your next exam. Okay? Let's take an example. If I purchase $4,000 worth of appliances, that may sound like maybe a lot, maybe a little, but for many of you, if you start in some house, if you're going to be renting a house, if it doesn't have appliances, you would have to purchase some. If you're buying a house, you may have to purchase some appliances. 4,000 would be in the ballpark for a range of refrigerator, probably a microwave, as well as a dishwasher. You could spend more or less than that, depending on the type that you bought or how many of those that you bought. But in this particular problem, we put 800 down. Well, let's make sure that we recognize what that 800 down means. That means I paid part of the 4,000. 800 is not all of it. So I have some amount left, a balance left. What do I have left? It's going to be the 4,000 minus what I put down, 800. That leaves me 3,200. That's how much I'm going to have to borrow. That's going to determine my monthly payment that I'm going to have to make for these appliances. So let's get our monthly payment now. I'm going to go MP for monthly payment. It is equal to our future value, which is the principal times 1 plus RT divided by number of months. So substituting in here, my principal now, it's what I still owe after I paid my 800 down. I still owe 3,200. That's my principal that I'm going to be borrowing. 1 plus my interest rate, which is 8%, which is actually pretty common in this day and age. And my time is for 3 years. Because this is my future value of the loan for simple interest, that is in 3 years. So I put the 3 in. But now, notice I'm dividing by number of months. Well, they didn't give me specific months, but they told me 3 years. There's 12 months in 1 year, 24 in 2 years. 3 years would be 36 months. So I'm going to be dividing by 36. I could have put 3 times 12 there as well. Now I just need to go with the calculator here. I would probably first get this bracket down. I would take 0.08 times 3. That would give me 0.24 plus 1 would be 1.24, all divided by 36. So I would take 3,200 times 1.24 divided by 36. And what I would end up getting would be my monthly payment here. Got to find it a moment here. For some reason, I'm having a hard time finding this one. Let's see what's there. It is. Turns out to be $110.22. I rounded off to the nearest cent. That means I'm going to be asked to pay $110.22 every month for the next 36 months to pay off what I still owed on that particular set of appliances. I would like you to think why now. This is again a much deeper thought here, but why did I say this is kind of a ripoff? Why would I say this seems to be kind of harsh? Not easy to understand, but here's the answer. We're paying interest, that's that rate times time, on the original 3,200. And that interest is being charged on 3,200 every one of those 36 months. So every month I get charged this interest on 3,200. That's a little unfair because I'm paying off the 3,200 1 month at a time. So after I've paid maybe 16 months, I have 20 months left. I no longer have a balance of 3,200, but I'm still getting charged interest on the 3,200. That's why add-on interest is typically a little bit of a ripoff, because you're paying interest on the full amount, even though it is far less than that as you're paying it off. I hope that makes sense to you, why that seems to be a little harsh. Okay? Let's take another example. This time, I am trying to purchase a used car. $10,000, maybe that seems like a lot, maybe it doesn't. When you're purchasing used cars, they usually go anywhere from probably $1,000 all the way up to $30,000, $40,000, depending on how new or what type of car you're borrowing for. $10,000 is probably a medium range ballpark. I want to figure out my monthly payment. So again, my monthly payment, MP, my formula for that, you remember, is that future value, principal times 1 plus RT, divided by number of months. In this case, I didn't put anything down, so I have to borrow the full amount. My principal will be the full amount, $10,000. My interest rate, again, fairly common for a used car. It's not that far off. My guess is a lot of times it would be 9 or 10%. And I'm going to pay it back in 5 years. So my T is going to be 5. But now I need to divide this by the number of months. 5 years has the equivalent of 12 times 5 months, or that would have been 60. Simplifying this, I have 10,000. 0.08 times 5 would be 0.4, plus 1 would be 1.4, divided by 60. You would now calculate that out to get your monthly payment. Again, that monthly payment this time turns out to be $233.33. Again, make sure you can do all these calculations on your calculator to come up with that. That means every month for the next 5 years, I'm going to be paying $233.33. Okay? That may or may not seem like a lot to you, but I would like you to notice this. How much do we actually pay for the car? Well, this is what I'm going to pay every month for 60 months. So my total payments, that's how much I end up paying for the car. Total payments are going to be 60 of those 233.33. Those total payments, when you're all the way done, are actually going to be $14,000, even though the car cost $10,000. You had to pay that additional $4,000 interest, and you were getting charged interest on $10,000 every month. Even though that balance was going down every month, we're still getting charged interest on the full $10,000. That's why it's a little bit of a nasty type of loan that you can take out. But you got to be aware, sometimes you don't have any choice. For example, you graduate from college, you're going to need transportation to get to and from work. You may have to purchase a car. You may or may not have $10,000 in your checking account to go out and just buy one. You might have to borrow the money to do it. Just keep in mind, it's probably going to be a lot better for you if you don't pay it back in 5 years, but try to pay it off in 2 or 3 years. Yes, your monthly payment would be more, but your overall payment that you pay when you're all done is going to be less than $14,000 if you can do this in 3 years or 2 years. So when possible, you make the number of months that you're going to pay it off a smaller amount, provided you can afford this. You don't want to be missing payments because then your credit rating goes down, your credit score goes down in a hurry. Our last example, we're going to talk about credit cards. And we're going to look at how they calculate their interest. Their interest has got some good things about it. For example, you don't get charged on the original, the greatest amount all the time. They actually determine an average daily balance. It's kind of a weighted average, which hopefully will make a little bit more sense to you after we go through. So that part is really better than the monthly payments, the add-on interest. What is kind of a ripoff, not kind of, it is a ripoff with the credit cards, is their actual interest rate is very, very high. That's how they make their money. Here's an example. The activity on Greg Johnson's Visa account for one billing period is shown below. Find the average daily balance. This average daily balance is like a weighted average, okay? The billing period goes from April 11 through May 10. The previous balance was 240, okay? That means that was carried over from the previous month. That is something you want to try and avoid if at all possible if you're using credit cards. If you're using credit cards and you're paying off the entire balance every month, they're not dangerous. They're very useful and very convenient. But if you are carrying balances over, that is where the credit card is making money off of you, making a ridiculous amount. They list it as 1.5% interest per month. But remember, 1.5% interest per month is actually 18% interest per year. That is a ridiculously high interest rate. If you are carrying balances over, they are charging you a ridiculously high interest rate on that balance. So if at all possible, this is my dad talking to you now, pay off the entire balance every month. Do not bring balances over. That's how they make money off of you. They want you to carry balances over. It's why if you had $240 balance, they would say the minimum payment is, and they would give you some small amount, maybe $30. But then that would mean you're carrying a balance over, which is exactly what they want, because that's how they make their high interest rates. Well, I had $240 balance. April 15, I made a payment. Again, I didn't pay it off. I only paid $100. April 22, I went out for dinner. I charged $45. April 25, I went shopping for clothes, charged $128. May 4, I was at a hotel for $73. We want to find our average daily balance. So here we go with that average daily balance. These numbers up here are the same numbers that I just had on the previous sheet. Remember, we had a balance brought over of $240. That was from April 11 all the way up to May. The 240 was the starting point. Now notice this, April 11 to when I made my payment is 4 days. So for the first 4 days, from April 11 to 14, for 4 days, I had a balance on my credit card of $240 for 4 days. I made a payment on April 15 of $100. That means I have $100 less on my balance. It's down to $140. How long would it be at $140? It would be from the 15th to the 22nd. So I end up on the 22nd, it of course would have gotten changed because I charge an amount. So from the 15th to the 21st is 7 days. I had a balance of $140 for 7 days long. It's because I paid off $100. But what happens on the 22nd? The next day, I borrowed $45, or I charged my credit card $45. That means this balance is going to be the $140 plus the $45. Notice that is what I put right here. So now my balance is $185. That occurred for these 3 days up until the 25th. So for 3 days, I owed $185. On the 25th, I went shopping and I charged my credit card $128. That's going to be added to this. Notice I added the $128 to that number. So now I owe $314. I'm going to owe that from the 25th up to the 3rd. So from April 25 to May 3rd, for 9 days, I owed $314.18. That was my balance. On May 4, I made another charge to my credit card of $73. So I need to add that 73 to the balance. So now I owe $387. And I owe that from May 4 to the end of the billing period, May 9. From May 4, to May 10 would be 7 days. For 7 days, was my balance. For 9 days, this was the balance. For 3 days, now we need a weighted average. Notice the weighted average will take these 4 days times what you owed each day. Then we have 7 days that I owe $140, 7 times $140. That's added to it. 3 days that I owe $185, 9 days that I owe $314, and finally 7 that I owe this. I want the average daily balance, so I divide by how many days I had. There were 4 plus 7 plus 3 plus 9 plus 7 days. So when I put all these products together, I got 8,280 divided by 30. My average daily balance was $276.01. Then the finance charge. here's where they make their money. Their interest is going to be this average daily balance times the interest rate, 18%, times this fractional part of a year, $4. It may not seem like a lot, but it's actually an 18% interest rate. That is a significant amount. You will be asked to figure out average daily balance. These numbers in red are what we mean by a weighted average. Sometimes you have weighted averages with your grades. You might have, for example, on your grades, you might have 20% for your daily grades. You might have 50% on your tests, 30% on some other project, whatever. That's an example also of weighted averages. We're not going to finish that off, but I just want you to know that's a very similar concept. As I mentioned, this lesson was a little bit shorter, which is fine. We just got done with the test. So I am assigning section 5.1 here. I'm assigning it this Thursday, right before Easter. It'll be due next Thursday, the Thursday after Easter. All right? You have a good rest of your day.